Hello students. So today I thought I'll just do a very simple Python for beginners. And what we're trying to do is we want to actually obtain the nth prime numbers. Now we know that prime numbers can be quite tricky because mathematicians today will tell you that there are infinite number of prime numbers. So if we were to actually just try to obtain the n prime number, if we don't set a cap on what the maximum n will be, is going to be huge, right? So I think most of our machines will die before we get the solution. However, so for this little exercise, what I'm going to do is I'm going to cap my n, okay, when we're getting the n prime number to 30,000. So you can see the condition. A prime number is a natural number with exactly two unique factors, one and itself. The first prime number we know is actually the number 2, right? So given an n, which is going to be our input, right, we're going to check that n is going to be in between 1 to 30,000. And then we want to find the n prime number within reasonable time. Why do I have this within reasonable time? Because one of the ways that we can actually obtain prime number is by brute force. We actually scan through every single number. So in this case, it's 30,000, right? Or depending on what our upper bound is, we just scan through all the numbers that we have and then keep trying to see if we get a remainder by dividing factors after factors. It's very expensive, right? So we not advisable. If you do that, then it will take a long time. So if you want a reasonable time, we will actually employ this sieve of what do you call it? I can't pretend to know that I can pronounce it well. The sieve of Eratosthenes or something like that, right? Pardon my pronunciation. So by using that um, method, we actually cut down the computational time. We have some test cases that we can actually check. We have, 30 to is 113, 10,000, 20,000, 30,000. So since the maximum n is 30,000, we know that the output will be 35, 350,000, 377. So what I'm going straight away going to do is, okay, I'm going to set my upper bound to 360,000. Okay, that will help. We got this upper bound is chosen because we know that it will not go beyond 350,377, right? Otherwise, there are actually more complex mathematics to actually calculate the upper bound, which involve logarithm, but that is not the objective of today's video. So how do we actually go about performing the sieve of Eratosthenes, right? We're going to start by setting everything to true. So we're going to have a list, and this list will contain 0 all the way to the upper bound, and we're going to set all the values to true. Okay. Then after that, okay, we'll set the situation where the 0 index and the 1 index to false, because we know that 0 and 1 are not primes, right? So we got that out. We know that the 2 is the first prime number. So we can start with p equals to 2, right? So we're going to start counting from 2. So then, of course, we will have a list that will collect all the prime numbers later. So after that, what do we do? Well, while p times p is less than or equals to upper bound. So what this means is when imagine when my p is at 2, so I'm going to start with 2 times 2. Okay, 2 times 2 is still within the boundary. So I'm going to continue. Why I do 2 times 2? Because multiples of 2s, right? Multiples of the p in this case is what we don't want, right? We're going to set it to false. Okay, if you are performing the sieve on a piece of paper, that's where you do all the crossing out. Okay, so we're going to look at p times p first to get the multiples of p. Since p starts with 2 then after that we will update the p, right? Multiples of 2, multiples of 3, and so on until we complete everything, run through the entire list all the way to the upper bound and clear all the multiples. So that's exactly what we are going to do. So you can see the command, right? Well, p times p, which is the multiple of p in this case, is less than or equals to upper bound. We are going to check if it is true, right? If it's true, then I mean the sieve is true. That means this is p is the prime number. So we start with 2, right? So definitely the first one is true. Then we will run through, okay, for the entire range of p times p, which is the next multiple of 2, right? All the way to the upper bound, and the step is p. So that's how we collect all the multiple. We're going to set it to false. So in the first pass, where p is 2, we're going to cross out 2 times 2 is 4. We'll cross out 4. We'll cross out, right, 6. We'll cross out 8. We'll cross out 10 and so on. We'll do that. Okay, once we go all the way to the upper bound, all the multiples of 2s is settled. We go p, increment p to 3, right? So now what happened is we go through one more time. This time around, all the multiples of 3 will be crossed out. Then after that, you go to 4. Now, 4, all the multiples of 4 are already crossed out. So, it doesn't hurt, right? So you just continue. And you'll keep going until eventually the multiples that we want to find is out of the upper bound. Then we will stop. Okay, so with that done, we will actually have a whole list where all the positions, okay, all the index that is going to be prime is actually set as true. So once we have that, we can now actually collect our prime numbers. So how do we collect our prime numbers? Is this section over here, right? So we'll run through the entire list one more time. This time round, if, right, the index, okay, is true, then we will append it to the list called prime, which we set up as an empty list at the very beginning. So we'll keep collecting, right, until it comes to a time where the length of the prime is actually equals to n and we can stop. Why we can stop here? Because we are looking for the nth prime. So once we have n number of prime number, we don't need to continue anymore. So we will break it out and we will return prime -1. So what this prime -1 index, what it does is that it returns the very last item, last element in the list, which is exactly what we want. It is the nth term. Since the length is going to be n, we break the loop there, right? So that's what this function does. So once with that done, we can go ahead and write the main program. So you can ask for the input while true, okay, the input, we'll ask the user to enter a number n in between the number 1 to 30,000, which is the limit that we set, right? Then we check, right, is the input s, is it numeric? Actually, we don't really need numeric, just in case, right? Somebody use a different language. We can use is digit, it's fine. Okay, we just want to check that it's digit, just in case the n value, the user try to put in a character or something, right? We can go is digit, it works as well, right? So if the now we cast it to integer because we know that this n value is a index, a position. It has to be an integer. So if it is more than 1, right, or equals to 1, which is what we want, or less than equals to 30,000, so that's the limit that we set. If it's inside there, okay, we break out of this little loop and then we continue our process, right? Otherwise, we'll ask the user to key in again, okay, to key in something valid. So we just keep calling it. So once it breaks, that means we have got a valid input. Okay, we can actually go to the output and we print out, okay, whatever is returned from our user defined function, and that will actually solve our problem, right? We managed to get an n prime. So just a simple exercise for you to try, right? Now that you've gone through, you maybe try it on your own. Then if you're stuck, feel free to check my suggested solution again as a practice. Okay, I hope you have fun doing this. Okay, this is really for people who are learning Python, beginners mainly. So all the best, have fun.